Matteo, and I will be your trainer for this BTW 300 course. So this is the official course of the Barracuda Web Application Firewall for the deployment of this product on premise. So appliances, virtual machines, and so on. This is, as you probably have noticed already, is going to be a distance learning class. So I know that for some of you, this might be a little bit weird. Okay, you are staring in front of a screen, and you are going to see me. Actually, let's think. This is much better if I do something like this. Okay, you're going to stare at my face and basically listen to me. Now, I want to have this course as interactive as possible. I know this is really hard to achieve with a distance learning class, but I will try. Okay, so I will unmute all your mics. So you have controls of your microphones. If you want to ask questions, please unmute your microphone, ask the question. Okay, let's talk during this course. Again, I know it's going to be weird. If you don't feel comfortable with the mic, or if you're basically sitting on a place where there is a lot of background noise, you can use the WebEx chat to ask me these questions. Okay, this is not a recording. I'm not a robot, so you can talk to me. All right. So I'm going to unmute all your mics right now. So your mics are unmuted. If you want to mute your mic, just click on the small icon that you have right username, and then you can mute your microphone. There is already a question: can we get the rights to record the session? Unfortunately, we do not record our, at least not the technical distance learning classes. So this class cannot be recorded.
Do you even understand me?
So
no questions.
there are still some mics that are open. Please close your mics if you don't want to talk with me. Okay, otherwise I will have to override it, and I will have to mute your mic. All right? So three guys still with the mics open.
I've done that.
Really nice trick is you have to ask, I think I have a problem with my microphone.
All right. Okay. All right. So what are we going to cover with this BTW 300 course? In day one, so today, we are going to, let's share the desktop again. We're going to first see an introduction to web applications. I'm sorry, WebEx sometimes screws up a little bit, everything. So first, we're going to see an introduction to web applications. So these topics are necessary to basically cover the basics that then we will use to configure the web application firewall. The web application firewall is a very, very, let's say, different product. Okay, depending on even if you have a network background, you will see that the WAF is configured in a different way compared to network firewalls or IPS and IDS and so on. So we need to have to cover the basics in order to then configure the web application firewall, because the web application firewall will just ask questions and say, for example, what is the maximum request line? Now, if you don't know what is a request line, how can you know the maximum value of the request line, right? So that's why we have to do the introduction to web applications. Then we will discuss about web application security or insecurity. We will see why web applications are nowadays one of the main targets used by bad people to, for example, extract data or to hack into systems. And we will discuss about different types of attacks. We will see what are the countermeasures that we can use to protect against this kind of attacks and so on. Then we will start with the web application firewall basics. We will see what is a web application firewall, what is the system architecture, how it works, and so on. This is the end of day one. This is the end of the day. Tomorrow we will start with the securing web application. So we will basically start to configure the WAF to protect our web applications, and we will run some attacks. All right. So we will basically use the attacks that we have discussed in today, basically in the web application and security module, and we will run these attacks through the web. and we will see what happens. Day 3, we will basically discuss about some additional features that we can use in the web, like access control, application delivery, and we will have some additional time that we can use in case you have questions regarding day 2. All right, day 2 is let's say, the core module. Everything that is related to securing web application is covering that day. So it's going to be a very, very, let's say, intensive day. Okay. Yes, of course. Can we have a copy of the slide decks? Of course. We have prepared for you some material that you can download from our website, which is called Campus. So if you go to campus.barracuda.com and you search for BTW300 space resource, you will see 3 resources. I actually see 4 because I am an instructor, so I can see the instructor files. Okay, so you will see a resource that is called Topology Diagram, Student Guide, and Lab Guide. Okay, now the Student Guide contains all the diagrams that I will use in this course. Okay, so you can find all the related information about whatever I say in this course and more. Okay, in the Student Guide. It's basically a handbook that you can then use in the future to review what we have covered today. Then we have a lab guide and a topology diagram, okay, because we will have some hands-on labs. Most likely we will have our first hands-on lab right after lunch or at the end of the day. It depends how many questions we have in the morning and so on. So if you want, you can basically download all this material directly from Campus. I will explain how to connect to the lab environment once we will start the first lab. All right. So campus.barracuda.com, search for BTW300 resource, and you can download all these files. Now, at the end of this day, or actually at the end of this course, you will be able to understand how a general web application works. Okay. Of course, we will not get into the specific details about web applications, web application programming languages, and so on. We will discuss about general aspects. Then you will be able to identify what are the most common web application security issues. All right. You will also be able to exploit some of these issues, but remember, this is not a hacking course. Okay. Even though we will cover some hacking techniques, the main goal of this course is not to show you or to teach you how to hack into a database using SQL injection, for example. All right. The main goal of this course is to show you how to deploy and how to secure web applications using the Barracuda web application firewalls. Okay, firewall. So if you have questions regarding a specific attack and so on, we can discuss it later. All right, at the end of the course. Okay, so this was just a little introduction of the BTW300. Now, some information about logistics and time. Now, I will try to make as many breaks as possible. Okay, because I know that is very tiring to stand in front of a screen and basically not doing anything. Okay, this is not like a classroom course. So I will try to do a small break every 50 minutes. All right, let's see if this is possible. And then we will have a long break, like a 1-hour break for lunchtime. Okay, I will try to use, let's say, relative time measures. Like I would say, we do a break of 1 hour because we have people that come from Italy, England, Japan. So it's going to be a little bit weird to say lunchtime. All right. So let's say in the middle of this course, we're going to have a 1-hour break where you can eat or rest a little bit. All right. So let's begin with the first module of this course, which is the introduction to web applications. Okay, and let's begin with the first crash of our beloved software Microsoft PowerPoint. Hopefully, it's going to be the first and last one. All right? So, okay. So, in this module, we will cover just a quick overview of web applications. So, basically, what are web applications and how they are basically how they work and how they are created. And then we will cover the hypertext transfer protocol. We'll cover HTTP. That, as we will see later, it is the layer 7 protocol, layer 7 of the OSI model protocol that web applications use to transfer data. Okay, so let's begin with the overview of web application. First, what is a web application? Now, the simplest way to define a web application is any client-server application that uses the browser, the web browser, as a client is a web application. I know that this is a very, very generic definition, but honestly, it is not easy to identify what a web application really is, even if you talk with developers, with web application security experts, and so on. It's not really clearly defined what a web application is. So for the, let's say, for the scope of this course, we say that any client-server application that uses the browser is a web application. All right? So on the right side here, we have a web browser, and the web browser is communicating with a web server. So somehow, this web browser will talk with the web server, so we'll give some input, like any application, and then the application will generate some output based on the input that we have provided to the web server. Okay, so we already seen two entities here, a web browser and a web server. Okay, we will discuss about these entities during this course. Now, the question is, how did we get to the web application? How web applications were created? Well, the evolution of web applications is actually a very interesting one, because it was very fast. I mean, web applications basically were created in, let's say, early 2004, 2005, and the evolution was dramatically fast. Okay. Now, if you consider what websites were when they were created for the first time, they were just static pages, right? So we had basically a page, and that's it. Okay. You had some links on this page. You could click on the link and go to another page, but there was no interaction, not real interaction with this page. Okay, the first website that was created at CERN was basically a static page, and we will see an example of this website. Then something happened. The browsers, let's say vendors, have started to integrate some scripting capabilities into web browsers. So they introduced language that it's called JavaScript. And JavaScript will allow you to have dynamic pages, so pages that will change based on user input, so user interaction, or based on some timed events, like after 5 seconds, after 10 seconds, and so on. So from a static page, we went to a dynamic page, something that we can interact with. The problem was that with these dynamic pages, that every time that you were interacting with these pages, the whole page would reload. Okay, the whole website had to refresh, basically. So this was okay, for example, in 2006. This is not okay in 2016. Why? Because think about it. If you're using, let's say, document editor, all right, that is hosted somewhere like the Google Docs. Let's say that you are writing on this document and you want to make a word bold. Okay, so you select the word and you make the word bold. Now imagine that every time you do this, the page would refresh completely. This is not a usable application. Okay, so dynamic pages were giving some control to the users, but still you would need a full refresh of the website in order to actually update the content of the page. Then something happened between dynamic pages and what we have today, web applications. And this something was the introduction of a small library that it's called XML HTTP request. This small library was introduced by Microsoft, actually, for their Exchange servers, for their so Outlook Web Access web applications. Now, at the beginning, they didn't fully realize what they were creating, because this is one of the most powerful libraries that were ever introduced in the World Wide Web world. This library, using this library will allow developers to create websites that were fetching content asynchronously in the background. So this means that while you are browsing your website, the website changes automatically or based on user input, and it doesn't have to refresh. All the requests and all the responses are processed on the background. Okay? You don't even see it. You don't even have to refresh the page. Everything stays in one page, mostly, and the content is updated in real time. The classic example of this, Facebook. Your Facebook feed. You log into Facebook, and then you scroll your feed, and as you scroll, the feeds actually will present you with old data or new data will be displayed on top, and so on. So these are real applications that you can use, and this is what they're called web applications. Okay, you will see that one of the most common way to create web application is by using some languages like Ajax, for example, JavaScript is always there, and we will discuss about this kind of scripting capabilities in a moment. So let's actually see this evolution. So if we take a look at the first website that was created by our beloved team, this is the first website. Okay, so it's a static page. It has some links. You could click on these links if you want. You go technical, and you got another page. Of course, my browser had to reload another page with other links. If I click on Design Issues, I will see another page with other links. Okay, so these were the first. This was the first website that was ever created. Of course, at the beginning, there were no browsers, so the real browser was actually a console browser. Okay, so basically you had to interact with this web page by typing numbers. For each link, there was a number. You type the number, you hit enter, and so on. But nowadays, we can use web browsers that would render the whole page for us. So this is the first website that was ever created. Now, let's take a look what happened in the real world. And for this, I will use the BBC as an example. All right? So this is the version of the BBC website in 1998. As you can see, we have a lot of text. All right? We have few images, small images, a GIF here, and there were a lot of hyperlinks. All right? Everything was a link. I'm not going to click on these links because this is a cached version of this website. Okay, so they most likely won't work. Now, if you're wondering why there was all this text except of images, because bandwidth was expensive, and also bandwidth was not that high bandwidth connections were not that available for normal consumer users. Okay, so maybe you were dial-up. You were using dial-up connections with 56K if you were lucky, or 33K, and you would load this website. So that's why we have a lot of text. All right. Now, if we move forward and we go to 2005, we still have a lot of text. All right. We have links, but then we start to see some interaction. You see here, this is an input field. We can search for the whole bbc.co.uk website, or we can search the web, okay, right from this input field. Okay, so as you can see, the website is actually evolving. Now, let's move from 2005 to 2010. Now, 2010, as you can see, we see more images, less text, and we can really interact with this website. We can, for example, edit this section. We can customize the SCI and environment section. We can search for website or the internet. If we click more here, an overlay menu will appear. Okay, this is JavaScript, by the way. Okay, so the page didn't really reload. It just created an overlay over this of the original page. Okay, but still, this is not a web application as we know it today. Okay, because if I would click or if I would search something here like London, okay, I would need then to click search to then have some results. Now, let's jump forward to the present day. This is today's BBC website. Basically, the text has disappeared. We only have mostly images. And let's try to use the search functionality. Let's click on search. All right. Let's write London. London. Oh, look at that. So the page is completely different now. We have a new search field, right? It has been expanded here. And while I write, the page is actually retrieving information from some data sources. Okay, so this page is changing in real time depending on what I'm writing on this search field. Okay, this is the asynchronous fetching of content. All right, the whole page doesn't have to reload, refresh. I'm just using this web application. Okay, so this was just a quick introduction to the evolution of web applications. Now, what about web applications today? As we've seen with the BBC website, we have the possibility to interact with web applications in a way that it would be as if we are installing a web application in our computer and then use it. Okay. Now the user experience is very similar. In fact, people have started to realize this, and web applications have started to be used with in any kind of environment. We have CRMs, we got intranet applications, we got office applications, we got online banking, social networking applications, and so on. Okay, so web applications today are everywhere. If you are a company and you would need to create a web application to provide services to your customers, you most likely create a web application and not a traditional client-server application. And the reason behind this is that if you use the strict model of the client-server application model, there is a very, very strict relationship between the client and the server. This means that you have a server, and then you have a client, and the client must be on the same version or compatible to the software that you have installed in the server. Okay, so every time that you touch the server, you have to make sure that the client is up to date or is compatible with the server and so on. Okay. Nowadays, this kind of let's say strict model is disappearing, but we still have this model. Think about Lotus Domino, for example, or even Microsoft Exchange. What's the client of Microsoft Exchange? Outlook, right? You install Outlook to interact with a server, client, server. What's the client of Gmail? There is no client, right? The web browser is actually the client. You don't have to install anything to use Gmail, right? So this is where we are actually going. And let's say that we are already there for some environments. Now, even the web application firewall is managed by using a web interface, which is a web application. Okay? Most of your networking equipment is managed using a web application. So as you can see, web applications are everywhere today. Now, the structure of a typical web application is made of different pieces, okay, or different entities. Now, these pieces are called tiers. And the first tier of a web application tier structure is the browser. The web browser is tier number 1. Okay? We said that the web browser is, in fact, the client that is interacting with what? With our web application, which is tier 2. So tier 2 essentially is the web application technology. All right? This could be the software itself that is written in PHP, in Java, in JS, whatever you want to use to write your web application. Okay? Now, this is sufficient to have, let's say, the normal web application model. But of course, you might want to interact, or you might want to fetch some data while you are using your web application. So that's why most of the times when you have a web application, you also have a database. Okay? You have a place where you save all your data, and this data can be retrieved easily. Now, in this case, the web browser doesn't interact directly with the database. The web browser interacts with the web application. It is then the web application that knows how to get the data from the database. And the database will reply to our web application, and then the web application will then present the data to the web browser. Now, the database could be hosted on the same servers of the web application. Okay, so you don't have to really have, let's say, a web farm and a SAN that hosts your database in storage and servers and so on. Okay, you can have a server that hosts the database and the web application technology. Now, nowadays, you can have something that is called the tier N model. The tier N says that basically you can use this model to basically create your web application structure, but you can have additional tiers. For example, let's say that you have to authenticate your users. You might use an authentication server. Okay, this is another tier. Let's say that you need to interact with a message broker, because depending on some events, the web application has to generate some actions. Well, that is another tier, and so on. Okay, so you can have additional tiers that are around connected to your web application. So let's analyze all these tiers. Okay, we'll start with tier 1, and we'll go to tier 2 and tier 3. Now, tier 1 is the web browser. Okay, we said that the web browser is our client. So the web browser must be able to communicate with the web application, but he also must be able to communicate with us, with humans. So he must understand web application code, and he must present this code to humans, to us, so we can interact with the web application. So one of the first things that the browser should do is to retrieve the information from a web application. In order to retrieve this information, the web browser uses some addresses that will basically locate these resources on the internet that are called URLs. Okay, we will discuss about URLs and URIs in the next chapter. Then that's not the end. Okay, that is just fetching the data. Then the web browser has to parse the data. It has to read the code that has been downloaded. All right. Remember that every time that you use a web application, the whole web application is downloaded into the browser. Okay, so you always use the most up-to-date version of the web application. Okay, let's say the published version of that web application. Okay, so the browser will then download and render all this code so that we can interact with the page. Okay, now if we take a look at the BBC source code, this is what the browser sees. Okay, but can you interact with this code? No, no way, right? This is the source code of the page. A developer might use this code to troubleshoot the page, to troubleshoot a problem, and so on. But this is not what we see. We actually see the BBC website. Okay, this is the rendering part. So the most important function of a web browser is to actually allow us to interact with web applications. All right. Now, what do we have on the other side? We have the web application technology, right? Now, this web application technology normally has to be hosted somewhere. Now, the typical example of a server that is hosting a web page is called a web server. Okay? Now, the web server will basically process all the requests that the browser is actually doing when we request a specific page, and it will provide with that page. Okay? What is the protocol that we are going to use? The protocol is HTTP, a layer 7 application protocol. Okay, so this is the protocol that web applications use to transfer data from servers to clients. Okay, now a web server is normally a very, very static server. Okay, it means that the main goal of a web server is to process the request, provide the response. So it is in the web server, of course, you have an operating system and a web server software. Okay, this could be Apache, this could be IIS, it could be Nginx, and so on. All right. Now, in the web server, you could find the web application technology itself. All right. You can install the web application in the web server. In that case, the web server is no more a web server. This is called an hybrid server, okay, because it hosts the web server software and also the web application technology. If the web application technology is hosted somewhere else, then you still have a web server, which is still the communication point between the web browser and the web application. And then you will have the web application hosted in another server that is called an application server. Okay? So this is very important because when you have to protect your web applications, you must be able to deploy the web in the right position, okay? Which is normally here, in front of your web server. All right, not in front of your application server. Okay, so this is basically tier 2, and we can have another tier that is basically hosting our web application technology. Now, when the web server will reply to our HTTP request, it will reply with an HTML page. Now, HTML is the language that is used in websites and web application to communicate to data to the web browser. Okay, so data is actually inside this HTML page, and the web browser is able to read this HTML page and to parse the code and present the code. Now, within this code, we can have some scripts. Okay. Now, some of these scripts are executed here, and other scripts are executed here at the web browser. Now, if the scripts are executed at the web server, in the web server, now these scripts are called server-side scripts. Okay, these scripts are normally executed while the page is loading. Okay, so you have, for example, a request to a website that is called myip.com. The web server will then process the request and will pass the request to the web application technology. The web application technology says, all right, I have to get the public IP address of this guy, and I will have to put it somewhere. Okay, so the web application technology will say, what's the IP address of this guy? Is 1112. Okay, all right. The web application then gives the information to the web server. The web server will then transfer the HTML page to the browser, and the browser will display the public IP address of that user. Okay, so the script was executed here at the web server or the hybrid server, and the response was, for example, a static page, that includes the IP address of this command. For example, if I go to icanhasip.com, this is my public IP address. What happened was that essentially client-side scripts were executed, and if we take a look at the page source, there is essentially nothing. It's just a number here. Okay, it's a very basic page here. Okay. Now, on the other hand, client-side scripts are executed in the browser, and client-side scripts are executed after the page is loaded, and they are executed locally. Okay, so the web browser will download the page, so it will receive the response from the web server. It will start to parse the code, and then when the web browser will see a script, it then will execute, okay, this script. Now, this script might modify the page. It might basically interact with the user. So the user, for example, he will the mouse he is hovering over an image, then a pop-up overlay window will appear, and so on. Okay, or it might start to interact with the web browser. Okay, using, for example, asynchronous requests. Again, like the Facebook feed. You scroll down. What is happening is that as you scroll down, the event of refreshing the content in Facebook will generate requests to the web server. The web server will then reply with the new content of your Facebook feed. Okay, this is very important. Okay, that you understand that client-side scripts are executed locally, because as we will see later, this could be a very huge problem in terms of security. Okay. Now, the last tier of our web application structure, tier number 3, is the database. Now, what the hell is the database? Now, a database is not a server. First, it's not a server. A database is a software. Okay? It is a software that will allow you to store data in a way that it is easy to retrieve. Okay, so we're not just putting a bunch of data there and say, oh, where is the, for example, information about that user, and then you have to search for that data. No, it is saved in a way that it is easy to actually retrieve it. Now, the software doesn't only save the data, but it also saves the structure of how data is saved. Okay, so typically a database is made of tables. All right, so you have tables that will contain rows and columns, and the data is inside, for example, a specific cell. All right, like for example here we have some data. Here we have another data, another type of data, for example. Okay. So if you want to make an example, this is like an Excel spreadsheet. But an Excel spreadsheet is not a database. Okay? This is just to make an example. Please don't use Excel as a database. It is not designed to be used as a database. All right? There is a question in the meantime. So if there is a new script, this is for client-side scripts. So if there is a new script, it is downloaded every time. That is correct. In the client-side script, if there is a new script, every time that you access a web application, you will download that script, okay? Unless some kind of caching technology is involved in the web application structure and so on, okay? Normally, every time that you have to access a web application, then you have to basically download everything, parse the code, render, and then you will get your web application. There is a clarification of the question. When we browse the Facebook feed, a new script will be downloaded in the backend. No. Or it could be, but normally it's not the case. When you download the Facebook web application, what happens is that you get the web application in the browser. The browser will then present you Facebook. Okay. Now, on the backend, okay, what is going to happen when you scroll? There is a script or a set of scripts that will instruct the browser to open requests to the web server to fetch new data to populate your feed. Okay, so these scripts are already running locally in your browser. Okay, now it could happen that one of these scripts is actually fetching another script. Okay, because maybe you are, for example, you are scrolling down with the Facebook feed, and I'm just making an example. You have the weather forecast for where you live. Okay, this might be the case where the browser needs to fetch another script, then to query another data source, and so on. Okay, but normally what you have is basically you have that the whole web application is downloaded, and then only data is exchanged. Normally you use XML or JSON to move data on the backend from between the browser and the web server. So there is a single script or a set of scripts that are downloaded, and then it just gets populated when requested. Exactly. I will actually show you an example. All right. I will not use Facebook. I will use our campus website. Okay. Let's go. I will actually log out. Okay. This is our campus website. Now, as I scroll down, more data is appearing, as you can see, right? Now, let's analyze this page for 1 second. Now, if you scroll down, actually, okay, script, all right? Now, as you can see, this is a script, okay, that it's going to download something from maps.google.com, okay? So this is actually a script downloaded from this website that is then executed. These are all the variables, okay, that we are setting on this script, and then it is executed by the browser. Okay, let's see if we can find another script. Here, there is another script that is basically, it's called, this is what pulse infinite text for FP indicator. Okay, the web developers have actually created all this stuff. Okay, so all these scripts are then executed by the web browser every time. Here there is another one, tooltips, for example. Okay, FP stands for prompt page. There is another script here that this is for when you land on the Barracuda website. Okay, so that's to connect two websites together. So if, for example, I'm going to browse, actually scroll down, sorry, the website is populated. Okay, content is fetched, and it is then presented to the user. Okay, this is like scrolling. Oh, here it is. This is Google Maps, basically. That's why we had that script over there. And these are the training centers of Barracuda University and external ATCs. Okay, so this is actually how scripts, client-side scripts, work. Does this answer your question? There is another question. So based on the tier model, the web browser asks the web application to download data from its server. No, the web browser normally interacts only with web servers, okay, or hybrid servers. It is the web server technology that then speaks with the web application technology, okay? Then the web application might ask the web browser to download, to fetch content from another site, okay? Like, for example, you are browsing Facebook and you're getting some advertisements for a pair of sneakers that you have searched on Amazon 2 hours before, okay? That's an example of fetching the data from multiple sources. If you analyze what you would say when you normally browse the internet, you will see that a lot of scripts interact with different websites, different systems. There are scripts that will optimize your page, depending on what device you're using. There are scripts that are connecting you to Facebook, Twitter, Google, and so on. Okay, so this is done by the browser. So opening all the connections to fetch all the data. All right, so we said that databases are a collection of data and its structure. This is important. It's not just data, it is its structure also. Now, there are different languages that are used to with databases to save the data, to read the data from databases. And these languages are normally specific languages. Okay, so for example, the main language that is used to interact, to query databases is called SQL, okay, SQL. Then we might have XQuery, we might have SQL XML. Now, depending on the database technology, remember, a database is a software. If this technology is developed by Microsoft, then you wouldn't use a pure SQL language standard to query that database. You will use the MS SQL standard to query that database. If you're using MySQL, then you will have to use the MySQL statements. If you're using Postgres, you will have to use the Postgres statements. They are all derived from the SQL language. Okay, so every database is different from each other. Okay, they are very similar to each other because they all have SQL as their father in terms of language, but there are different commands, things are saved in a different way, and so on. Now, in order to interact with databases, you can use something that is called a SQL query. Okay, a query will allow you to retrieve data that is saved in a database. It will allow you to save data. It will allow you to change data in a database. For example, let's say that in this database that is called catalog_db, we have a table that is called movies. In this table, we have 3 movies: The Matrix, The Godfather, The Fight Club, with their years and their prices. Now, if I use the SQL language to create the query, I will have to write something like this: select wildcard from movies where year equals 1999, ordered by title. All right. Now, how do I know how to create this SQL query? This is documented. Okay. This is a language. You have to learn it in order to understand how to interact with databases. Normally, you don't do it. Web developers will do it for you. Okay. Like in the BBC website, you search for London, and you get all the information that are related to London. Okay. You don't have to select wildcard from whatever, where the item is London, and so on. Okay. The result of this query is that we have Fight Club and The Matrix, because they were published in the year 1999, and the price is 15 and 10 euros, dollars, pounds, whatever. Okay, and they are ordered by title. Okay. Another query: select title from movies where price is more or equal than 20. Okay, in this case, the result is only The Godfather. Okay. There is a question. So it is fine if you're not thorough with the language. So is it okay if you don't know how SQL works? Well, it is okay. Okay. I mean, you can configure the web application firewall even if you don't understand how SQL works. The problem with web application security is that you should have a very broad understanding on how all the elements work, because there is a very wide attack surface. So the way that hackers can hack into your web application is there are many ways, and some attacks are linked to each other. Okay, so you can use an attack to then perform another attack. Okay, so the more you know about these languages, the more you know about databases, the better it is actually for you as a IT security professional. Okay, it's like saying, do I have to know how a UDP packet actually is made of when I'm configuring a firewall? No, not really. You just have to know that the protocol is UDP, and then you have a port. Okay, and of course you might need a source IP and a destination IP. Then, if you know it, that's better. Okay, because if something happened, then you might be able to troubleshoot what is happening. If you don't know it, well, then it's one of your limits. Okay, so my suggestion is, of course, you don't have to be a developer, but if you're interested in web application security, dig down into these topics. Okay, this is just an overview. Okay, so we're just scratching the surface of these topics. It's up to you then to get the knowledge. At the end of this course, on day 3, I will give you a list of books that you can use to expand your knowledge on web application security and web applications in general. All right? So how does this SQL query look like in the web application? This is how it looks like. We have exactly the query that we've seen before, but in this case, this query is stored in the web application. So our user that we call Tommy for our course doesn't know anything about SQL. It doesn't know anything about web applications. It doesn't know anything about databases. It just opens a browser. It goes to movies.com, for example, and that website has 3 input fields, which will allow Tommy to insert the title, the year, or the price of those movies. Okay? Then a submit button might be here, just to submit a request. So what it will do, it will just put 1999 in the year and click submit. Then the browser will do the HTTP request. The web browser, the web server, sorry, will then pass the request to the application technology that has predefined the part of the query where we can only have as a variable the year, okay? And then it will send the query to the database. The database will then basically provide an output. The output is very similar to what you see here. Okay, it's just the output of the database. Then the web server, the web application technology will generate a very nice and beautiful page, and then will be sent to the web server. Then will basically send the HTTP response to the web browser. Okay, remember HTML is always used. So essentially, this is how we interact with databases. We never, ever interact directly. We always go through web applications. Okay? Always think that the web server is your first point of contact. Then you have something. Then you have something else. Then you have something else. All right? Web server, web application, database, authentication software, and so on. Okay? Now, what we have seen in this chapter, it is valid. It is still valid today. But since the web application technologies are advancing very, very rapidly, you will see nowadays that there are other topics that should be considered. For example, there is a new topic that it's called microservices, okay, where in reality, your web server, your web application server, your application server, and your database are just containers. So where are these containers? You don't know. Okay, you have a lot of servers that host containers. So you can have multiple web servers that are spread out to different servers. The same for databases and so on. Okay, another topic that is actually discussed recently is the validity of calling web applications what normally it is a website with some web application technology behind it. I mean, if you open Word, okay, and you interact with Word, Word never refreshes. You never change the Word page, okay? Like if I open Word here and I open a blank document, this is my software. I can write, okay, I can change the text, I can for example, change the page layout, put more columns, and so on. I am still in the same window. Okay, this is possible nowadays with web applications. And if you see a web application like this is called an SPA, a single-page web application. Okay, an application that never, ever refresh the page. Everything is contained into this. People have created all sorts of web applications in SPA. For example, there are operating systems that are emulated into single-page web applications. Okay, there are, for example, game emulators, and so on. Office software, Office programs are emulated in SPA. Okay, for example, the Google Docs. Okay, or the iCloud software, and so on. All right. So, do you have any questions regarding the first chapter of this module? There is a question. How is new data retrieved on single-page applications? It is retrieved using asynchronous transfer. Okay, so using AJAX, for example, or AJAGE, which uses JSON as a type of markup language to transfer data. So basically, they are like the BBC website, you have to imagine like if you're using the BBC website. But if you click capital, you don't have a refresh at all. All right. The whole content changes within the same application window. If I click on this, I will basically stay in the same web application. Okay. You see here, every time that I click on something specific to this website, the whole page reloads. All right. Now, in single-page applications, this doesn't happen. Everything is contained in one page. All right. If there are no other questions, I would do a 5-minute break. OK? So you can, for 5 minutes, not looking at the screen. And